So welcome to this session. This is a session dedicated to civil and environmental engineering. This is a course, this is a brand new course that has been launched this year by Politecnico, and it's fully taught in English. So I'm going to speak English. How many of you are Italian and how many are not? Can you raise your hand, please? You are not? All Italians but one, okay. So the peculiarity of this course is not, well, yes, one is that it's in English, of course. But that's not really the main peculiarity. This is a very interesting and modern course, in my opinion, that combines two areas of engineering. One is civil engineering, and one is environmental engineering. Combining two, we have civil and environmental engineering. Okay? So this is the trick. I would like you, so my job today is to tell you why, what does that look like, what type of problems you are going to deal with as a civil and environmental engineering. And of course, I'm here to answer all your questions, okay? If you have any. Please feel free to interrupt me anytime during this talk, okay? I keep this talk usually very informal, very light. What we're going to do now is a quiz, a game together. And my job is to, main message I would like to deliver to you is that both civil and environmental engineering are extremely transversal. Okay? You will learn many things. The civil engineer and the environmental engineers are typical problem solvers, that they know how to deal with many problems. They have a very wide overview of problems related, of course, to civil and environmental engineering. Okay? Now, before we start, we've got some new guests. Please come in. Oh, very good. Okay, that's the expected number. Very good, guys. I just started. No big deal. I was just explaining that this is a very informal presentation. I'll try to tell you what civil and environmental engineering is through a quiz. Okay, so we're going to play together. I hope you all have a phone. Do you? A smartphone? Okay, good. So we're going to use it. So you can keep it. And I'll try to tell you what civil and environmental engineering is. So before we do that, could you please open up your browser of your phone and go to www.kahoot.com. Now you should see a page, purple page, where you are asked to get a pin. Okay, the correct pin to participate to this quiz is 5838526. Okay, let's see who plays. Only one. What? 3. You can use a nickname if you want. Let's see. Okay. Very good. let's see, the 9 is the amount of people in here. Let's see if there is someone from, let's wait a few seconds to see if there's someone from home, because we are streaming. Doesn't look like. Okay. Okay, guys, so what we are going to do is a little quiz. So we're going to play together. And through this quiz, you're going to, hopefully, I'm going to tell you what civil and environmental engineering is. Okay? We can start. Okay, this is the initial page. Italians like to call this orientation day. This is not incorrect, but a bit weird. But anyway. Next. Before we start, and I tell you what we do in civil and environmental engineering here at Politecnico, let's get to know each other a little bit better. My name is Costantino Manes. I am an associate professor here at Politecnico. I teach in civil and environmental and mechanical engineering courses. And please come in, see? Okay. And I'm the admission tutor, okay, for the civil and environmental engineering course. So I take care of you, essentially, of people who wants to come and study in here. If you have questions, you can come to me or my colleagues down to the stands and so forth. Now I want to know why you are here, essentially, and I want to know a little bit from you. First question I have for you is not a quiz, it's a poll, is the following. How confident are you about enrolling in a civil and environmental engineering program anywhere? Totally, very, but I would like to gather more information. Not much. I'm here just because a friend is here. Or no way, can I leave? Please don't answer the green one. Not much, but let's give it a go. Okay, so we have 0170. Let's see if I do my job rightly today. Okay. Let me ask you another question. How confident are you enrolling in a civil and environmental engineering program at Politecnico, at PoliTo? Slightly different question. Same answers, totally, very, but I would like to gather more info. Not much, but let's give it a go. No way, I'm going elsewhere. Let's see. Very, but I would like to gather more info. And okay, so we are essentially aligned. Very good. Let's give it a go then. Now, this course, Civil and Environmental Engineering, aims essentially at training an engineer with with skills taken from the civil engineering area and the environmental engineering area. Okay. Why is this important? If you look at top-notch universities around the world, including PoliTo, you will see that many civil engineering alone and environmental engineering are more and more merged, especially at the bachelor level. You will find a lot of civil and environmental engineering courses. This is absolutely necessary because nowadays it is essentially impossible to design any structure, any infrastructure, anything without considering environmental aspects, okay? So the two problems of designing structures, designing things, building things, and assessing what is their environmental impact, they go together. So environmental engineers will benefit from learning how to build things. We will see what that means in a second. And civil engineering will learn how to deal with very important challenges that wait ahead. What is the most important challenge you will deal with after you graduate? I would say climate change. Would you agree? We have to live more sustainably. It's not just a matter of politics, it's a matter of technology, it's a matter of designing houses, buildings, and everything that are more sustainable, dealing with waste, dealing with industrial processes that are more sustainable, dealing with extreme events. Civil and environmental engineers will be at the forefront of all these problems. I would say playing one of the major roles. But anyway, one of the classical topics studied by civil engineers is the design of big structures. Do you agree? Did you know that? Yes or no? Move your head. Yes or no? So, civil engineers are known for being constructors, for being engineers that are able to design and build marvels of technology like skyscrapers, okay? And this is not an easy job. One thing that you have to decide is how big are the columns, how big are the beams? These are typical questions that the engineer has to ask himself or herself. And the other one is, what is the loading, the force, the big problem that drives the most the design of such tall structures? So my question for you, in your opinion, let's see if there is some talent in here. When you deal with the skyscraper, what is the loading that is more important for the structural design of it? The loading coming from the wind, the earthquakes shaking, the weight of people and objects at each floor, the weight of snow. This is a typical question that the civil engineer has to address in his career when designing such enormous structures. What is your opinion? Let's see. 7 answers, 8. Okay, wind loading is the correct answer, and the most frequent answer was the weight of people and objects of each floor. Strange enough, whenever you have to deal with very tall structures, you deal with the wind. The wind is not much because it imposes very strong forces. It's because it generates vortices that make the whole structure sways at frequencies that are extremely dangerous. So studying the dynamics of structures and not just their static behavior is one of the great skills of a civil engineer. We will see at the scoreboard. Okay, so we talked about structures, which is what you will be trained with if you do civil and environmental engineering. Being able to design structures of concrete, of steel, is one of the core subjects of this course. Is absolutely important and belongs, let's say, more typically to the civil engineering area. Now, let's talk about structures a bit more. I was saying air is not just a threat to structures, like we learned earlier on with the wind. It can be an opportunity. Did you know that we have pneumatic structures that are essentially there are balloons filled with air, like the Allianz Arena Stadium in Germany, for example. That's a very iconic structures. The question I have for you, when you design it, the air inside of the balloon, what do you think? Which one of these statements is true about the air pressure inside the balloon? Is it lower than the atmospheric pressure? Is equal to atmospheric pressure? It doesn't matter how pressure is distributed, or the air pressure inside the balloon is greater than atmospheric pressure. If you want to design these structures, what would you do? answers. Three, four. Get in there. The air pressure inside the balloon is greater than atmospheric pressure. Of course, otherwise the whole balloon wouldn't have any stability, any rigidity. So it would just crash down. Absolutely. So structures are not just, in civil engineering, you really need to be creative, are not just made out of concrete and steel. There are many examples of structures that are built out of things that we wouldn't expect at all. So there is lots and room for creativity. Now, in my opinion, when we talk about civil and environmental engineering, the best example of a structure that involves an enormous amount of skills to be designed, this is a fluvial bridge. So a bridge that allows to cross a river, okay? I call this light Bridge Over Troubled Waters, out of a song by Simon and Garfunkel in 1970. The song talked about friendship, essentially. Here we talk about disasters. If these type of bridges are not designed correctly, people die, and they have an enormous impact on the economy. Usually, the economic impact of a bridge collapse in terms of disruption of mobility with cars and trains is 10-15 times greater than the cost of rebuilding the bridge itself. So we need to design them properly. And to design them properly, we need really the skills of the civil engineer, let's say, and the environmental engineer as a whole, because here we have to design the bridge as a structure, correct? Am I right? Which is the typical field of civil engineering. We have to design what is called the foundations. You know what the foundations are? Foundations are the lower part of the structures that interacts with the soil. In this case, with the river bed, okay? The sand, the clay, the sediments that are at the bottom, all right? We need to design them properly so that the soil or the rock, whatever we have underneath, can sustain the weight of the bridge itself and of the cars, buses, trains, whatever passes through. Okay, so we need the structural engineer that designs the bridge as a structure. We need the one who designed the foundations, who is called the geotechnical engineer, from geo, which is earth. And then we have another typical civil and environmental engineer, which deals with the water underneath. And that's the hydraulic engineer, like me. I am an hydraulic engineer. I deal with water. The hydraulic engineer tells the other engineers who are working together what is the velocity of the water in the river during a flood and how strong it will impact the structure of the bridge. What is the water depth? And most of all, how much water is going to flow in the river during a flood, which is an extreme event. Have you ever heard of the words extreme events recently due to climate change? Imagine in the future how many extreme events we will have in the future and how important will be your job to tell to society, to politicians, to bridge owners, are these bridges built in the 80s? Well, this is much older. But how our bridge is built in the 80s, in the 70s, or even earlier, when we didn't know about climate change, are they going to stand against the extreme events that climate change will induce very soon? This will be your challenge as civil and environmental engineers. And what will be the effect of these floods on the territory, on the land where we live, on the cities? How are we going to defend ourselves from that? This is what the civil and environmental engineer does. Okay? Now, in your opinion, when we deal with bridges over water, what is the most frequent cause of bridge collapse? The erosion of sediments around the foundations due to the water flowing. The hydrodynamic loadings on the structure, the pushing of the water against the piles or the foundations in general. The loading of winds, the impact of rocks and debris like trunks on the piers. What do you think is the worst? Correct answer was the erosion of sediments around the foundations. Most of you thought it was the hydrodynamic loadings on the structure. When we deal with civil engineering, we deal with non-trivial problems. We deal with interconnected actions between the structure and the environment, like in this case. What happens during floods is that the water flows around the piers. These are the piers. Look. These are the piers, okay? Around the piers, you form a lot of turbulence that removes the sediment underneath. And without the sediment, if you remove too much sediment, the foundation doesn't have any ground to hold it and collapses. Do you know how many bridges in Italy collapsed? Bridges over rivers collapsed in the past 20 years due to this problem and others. Say a number. 1? Who thinks is 1? 10, 100, or 1,000? We had 150 collapsed bridges. At least. Many others were not documented, okay? For small bridges. This is an enormous amount. People are in danger. We do need civil and environmental engineers to avoid this, because it has an enormous impact, okay? So we talked about bridges. What goes over bridges are cars. Often, could be trains, can be anything. Cars, what's the problem with cars in your opinion? Tell me, what do you think? They pollute, correct? Not many people have electrical cars. And they create also problems for safety, okay? If there is a big traffic jam, a problem. Transport of goods and people slow down if there are traffic jams around, okay? So the traffic has to be managed. And managing a network of, of infrastructure like roads, railways, stuff like that, it's extremely important, and it's a job that is done by civil engineers, civil and environmental engineers. Why environmental? Why we need also the skills of an environmental engineer. Environmental engineer, if you attend the other courses, my colleagues will tell you that deals a lot with pollution and ways to manage pollution in cities, anywhere, okay? Not only to prevent the pollution to be emitted, but also to manage, to know where it goes, the dynamics of pollutants. This is what a civil and environmental engineer does. In the case of traffic, the civil and environmental engineer is able to plan the network through mathematical models, okay? The network of infrastructures to allow the transport actually to occur. And also, in a smart way, to plan the logistics of public transport, for example, in cities, to minimize the impact of private transport, which creates problems, creates traffic jams and a lot of pollution. We need to lower the pollution levels in cities. The impact of public transport has been documented to be huge in a city. If we all used public transport instead of cars, what would be the effect? How many cars are required in an hour, 60 minutes, to match the transport capacity of a bus passing by every 10 minutes? A bus may have 150, 200, let's say, people capacity. Okay, so a few hundred, a few tens cars, thousands of cars, about 50 cars. So how many cars are required for the same capacity of people of one bus or a tram? A few hundreds, absolutely. So if we use the bus or the tram in a typical scenario of a big city, we save ourselves tons of CO2, tons of greenhouse gases. You know what greenhouse gases are? CO2 and CH4, methane and carbon dioxide. These are responsible for climate change. We need to diminish the emission of this. And how much pollution we save? A lot. Tons of NOx or other stuff which is harmful for us. Who is leading? CEO. You take your car, you go around, you don't care about public transport. The other problem you get is that you have to park the car very often. And besides the lack of park space, you need to be careful where you park. Say that you go to the mountains. Here in Turin, we have beautiful mountains in the surrounding area, and you park it near a slope where there are some rocks. Who do you think tells people about whether there is a risk of rock falls or not in a slope? Is it the geologist? Not really. Are civil and environmental engineers, big experts, geotechnical engineers with also skills in geology. In this case, you have a big rock which weighs 250 kilonewtons, forget about it, a very heavy rock, okay? That has an angle, a friction angle that can be 25 degrees. Do you know what the friction angle is? Whatever you put something over a plane, whatever, the chair, and then you increase the angle until this object starts to move because the weight component along the plane is stronger than the friction force, whatever, okay? So the angle of friction of this rock in its state is 25, and the slope of where the rock is leaning is 27 degrees. So what happens now to the man and to the car underneath? The rock slides and hits the man. The rock slides and hits the car. The rock tumbles and hits the man. The rock tumbles and hits the car. What do you think is the correct one? The question is, I want to know whether it slides or tumbles, and in both cases, whether it hits the man and hits the car. Most of you said the rock tumbles and hits the car, whereas the correct answer is the rock slides and hits the car. Just slide. Not an easy question. This is what happens. It doesn't tumble because the weight force falls within the leaning area of the rock. So it doesn't tumble, it just slides. Okay. Stability of slopes are typical subjects of environmental engineers, of civil engineers, who design even protection structures against rockfalls, which is extremely important for our safety. Now, when your car is broken by a rockfall, you need to go to the workshop, to a mechanic, and fix it. Am I right? Who helped fixing you the car? Well, for sure, a mechanic. Don't ask an hydraulic engineer to fix your car. It's not going to work. But the hydraulic engineer can design the things you need to lift the car. A car of weight 1,500 kilograms leans over a plate of area A1, 15 square meters. Okay, and on the other side, you have a U-shaped tube which is filled with water. The blue thing here is water. And on the other side, on another plate, which is A2 with an area of 0.01 square meters, something like that. Okay. car is very heavy. The hydraulic engineer is a magician of hydrodynamics. He knows even fluid statics, as in this case. They know very well and use the principles to answer this question. Well, some more serious questions, but also, you know, principles are very similar. This is the stuff you're going to learn. Two packs. So what needs to be placed on plate A2 to hold the car from sinking? What's the minimum force that you have to apply to hold the car where it is? The weight of 2 packs of pasta, 1 kilogram. You just need a feather. Not enough time. You need at least 15 kilograms. You need at least 1,500 kilograms. Well, the correct answer, the timing was very fast, is 1 kilogram. So you just need to push for 1 kilogram to lift the car. And this is the principle of hydraulic jacks that are indeed studied in hydrodynamics, and tells you that with little force, if you balance the pressure, not the force, that's what counts, you can lift anything, even with your own strength. You can lift an elephant, you can lift really heavy stuff with the principles of hydraulics. So, what did we talk about? We talked about structural engineering, we talked about geotechnical engineering, we talked about hydraulic engineering, correct? We talked about transportation engineering. Where do we go? Where is the public transport, blah, blah, blah. The network. Now, a typical topic that is studied in environmental engineering a lot, and in civil engineering, it's called geomatics or survey. I mean, environmental and civil engineers are experts in surveying, on taking the world and map it, put it on a drawing, okay? Or are extremely good, really expert using high tech to position things correctly. If you are designing a skyscraper like before, or a bridge, you need to tell to the builders where to build, you know, the abutment, where to build the piers, exactly at that location. It cannot be half a meter away or half a meter before or behind. It has to be exactly one position, correct? Who is the expert of that? Is the geomatic engineer. Okay. Now, one thing in the old days that survey, let's call it like that, engineers must have been good to do was reading a map and drawing a map, okay, for other engineers to be used to build what they want to build and to do whatever they wanted to do. So the question for you is, look at Greenland and look at India, okay? In your opinion, the surface area of Greenland is the same as that of India. The surface area of Greenland is smaller than India. The surface area of Greenland was way bigger than that of India. The maps prove that Earth is flat. What's the correct answer? Of course, I'm talking about the real surface. So do you think that Greenland is bigger than India, smaller than India, looking at this map? The surface area of Greenland is way bigger than that of India. This is the most frequent answer, but the correct answer is that Greenland is a lot smaller than India. What's the problem here? The problem is that the Earth is kind of spherical, okay? Not exactly, but it's spherical. And when you want to sketch the world on a plane, you have distortions. And in these maps that you are used to watch, distortions make whatever is in the north or south poles look a lot bigger than what they really are. In reality, Greenland is much smaller than India. India is way bigger, okay? So all these mathematics, all these principles about mapping are studied by civil and environmental engineers, like, for example, as well as technology to locate things, to locate ourselves, probably technology you use today to come here, GPS, positioning. You have them in your car to know where you are at any moment, where you're driving, where you're going. And the technology is based on satellite. Okay? stuff that is really far away. And do you have any idea about the precision of GPS in finding real-time objects? What do you think it is? About a micrometer, 2-3 millimeters precision, about 1 meter, about 2-3 centimeters. I'm talking about real-time positioning, so things that move. What is the precision that we can have through the use of satellites? There's a lot of knowledge behind this stuff that survey engineers exploit for their work. Very good, about 2-3 centimeters. This is incredible in my opinion. And that's what we use very often to survey the world around us. We have to go fast here. Quanto tempo? Okay. Okay, now we talked a lot about traditional engineering subjects. You may have heard about surveying. We talked about geotechnics, soils, structures. We talked about pollution. We talked about what else? Hydraulics. We talked about many things that you're going to study as civil and environmental engineers, especially if you come here working with us at PoliTo. Now we talked a lot. We are hungry. It's almost lunchtime, am I right? So all this traveling made me hungry, but I want to eat sustainably. Have you ever heard about this word, sustainability? Sustainability is a word that in general defines a way of producing things in industry, of living that has a minimal impact on the environment. And this is the key word in the next 20 years, 30, 50 years, that will drive most of the jobs that are out there. Whatever you do, you have to do it sustainably. Okay, there's no way we are going to address any problem in engineering without looking at sustainability. And this is a branch that belongs a lot to environmental engineering, which is in this course, civil and environmental engineering. You will learn the concept of sustainability in many aspects, and it's pervasive, it's everywhere. Any industry, the food industry, the construction industry, anything, go to any website of any company you know, a big one, you will find a part dedicated to how sustainable they are. Okay. Now, eating is a big thing. We all need to eat. We all need to find food. What is the best way to eat sustainably, in your opinion? So I decided to have a burger today. And to have a burger, there is meat, there is vegetables, there is bread. And to produce lettuce, tomatoes, whatever, we need what? Water. We need a lot of water to grow plants, to grow plants that we use to feed animals like corn. And water is not, you know, we have a limited amount of fresh water in Earth. We cannot waste water, okay? We cannot pollute so much water. We have to be careful with the water we use. This is a major problem in many parts of the world, especially because with climate change, many parts of the world will experience more and more droughts, dry seasons, extreme dry season, like we are experiencing now here in Turin. It hasn't been raining seriously for a long time. Okay, water supplies are struggling. This will happen more and more often, not just extreme events with a lot of water, but extreme events with no water. This is a major problem in many parts of the world. So we need to find ways to minimize the amount of water. My question for you is, what is the volume of water required to produce 150 kilograms of beef? Whatever you find, okay, like a steak, or whatever you find in a beef. Half pint of water, 100 liters, 2,000 liters, 10 liters. That's correct. We need 2.5 cubic meters of water to make something this big. 2,500 liters of water gone virtually in what? How long does it take to eat a burger? If you're hungry, 5 minutes. After a burger, why not having a coffee? Coffee is important. Okay, many companies, coffee companies ask what is the best way, the sustainable way to deal with coffee. Sustainability is pervasive. So the mocha versus the machine, what is more sustainable? Drink coffee from mocha, like Italians do. Drink coffee from a machine, like many Italians do. Mocha and machine are equally sustainable. Forget about coffee, I want another burger. What do you think? Are we working in favor of ecology when we have a coffee from the electric machine, or when we do a traditional mocha? What do you think? Drink coffee for mocha. This is correct, but let me tell you, not by an enormous amount. When you do analysis from a sustainable point of view, and many coffee companies did this job, the coffee from mocha is better for emissions of CO2 and for energy consumption. This is you know now these days how important energy supplies are. Okay. The water, from a water consumption point of view, for example, the machine is better. But for the waste, clearly, with all the capsules that the machine uses, using a mocha is much better. This is just a joke, an example, a simple game to tell you about all the problems related to sustainability. You have a lot in the civil and engineering area. How to use, where to put construction materials, where do they go? How long do I need to transport them? How much does it cost? How much pollution I'm going to emit to put them from one place to another. These are all problems addressed by environmental engineers and are very important and will drive the economy of the future. I'm telling you. Any questions for me before we see the winner? Usually you don't, but I have a question for you. At the beginning, I asked you whether you were, how confident you were about coming to study civil and environmental engineering here at Politecnico. Now you have seen this talk, you have learned about hydraulic engineering, structural engineering, geotechnical engineering, sustainability, problems, okay, floods, droughts, problems that are addressed within this course. So perhaps you have a better idea what civil and environmental engineering is. So I'm asking you again, tell me a little bit more about you. How confident are you about enrolling in a civil and engineering program at PoliTo? Totally. Very, but I would like to gather more info. Still not much. No way I'm going elsewhere. Don't be nasty. Let's see. I thought this is a big improvement. We had majority earlier on about not much, but let's give it a go. So now we have majority about very, but I would like to gather more info. So this is a success. Guys, thank you very much for your attention. Let's see who wins. Tiziano is third place. Plata second, and the first, ladies and gentlemen, is Julie. Well done, Julie. Okay, guys, I'm done. I'm sorry, apologies, I've been a bit late. If you have more questions, I'm around. My colleagues downstairs have a lot of information to give you if you want to get more. I really hope to see you all in our class in the coming years. And I wish you a very good day and good lunch. No, still early. Okay? If you have questions, I'm here. Thank you very much and goodbye.